So today we are going to be talking about bicarbonate replacement, okay, in the body. So usually the bicarb level in our blood is almost 22 to 24 milliequivalent per liter, right? And how do we find this out? Via ABGs, okay? ABGs are done, arterial blood gases, to find out the pH and the bicarb level and the carbon dioxide and oxygen in the blood. So basically whenever bicarb is decreased, we have to replace it. But the question is that whenever it is low, are we supposed to start replacing it, or is there a cutoff? So the cutoff is that we have to look at the value of the pH. Theoretically, according to CMDT, until the pH is 7, you are not supposed to replace bicarb, okay? As soon as the pH drops, before normal pH is 7.35 to 45, right? 7.35 to 7.45. As soon as the pH drops, it hits 6.9, you are supposed to start replacing bicarb, okay? You're supposed to replace bicarb. Now the question is, when does this happen? Bicarb is basically decreased usually in cases of metabolic acidosis, and in ER we see that in DK, okay? But what do we do in ER is that we don't follow this value, like we don't wait for the pH to drop to 6.9 to replace bicarb. Whenever bicarb is low, whenever it hits 15 or below that, we start replacing it. Even if pH is 7.2, we don't look for this. But theoretically the cutoff is 6.9, that if the pH is below 6.9 and then bicarb is low, only then you are supposed to replace it, okay? Now the question is how to replace bicarb. So it's a very simple formula, that first of all you have to know that that 24 minus the value. Okay, let's say that the value is 5. Someone's bicarb is 5. Patient is in severe acidosis, 6.8, 5 is the pH. A patient of DKA, right? And ketones are positive, and you are you have seen the ABG 6.85 is the pH, and bicarb is 5, very low, right? So now 5 is the value of X that you are going to subtract from 24. The usual value is 24, okay? So the normal value minus the value that we acquire, right? And then what do we do is that we multiply this with 0.5, and we multiply this with the body weight, right? And then I think there's a cockroach, okay? And then we calculate the value, right? So basically, let's say the patient is 50 kgs, right? So that would be 50 into 0.5 into 19, right? So that would be 50 into 19. So that would be 25 into 19, right? So I'm going to do 475, okay? So 475 is the value of milliequivalent per liter. Now we have to convert this into ampules, okay? So this is, as we can see, 1 ampule of bicarb, and we can see that it has 20 ml of solution, and basically each ampule has 20 milliequivalent of bicarb, okay? And ampules we have to get. We know that 475 milliequivalent is the amount that needs to be replaced, right? So for that we are going to divide 475 with 20, because each ampule has 20 milliequivalent of bicarb, okay? So the answer is 23.75, which is almost 24, right? So the answer is that you have to replace 24 ampules. But the story has not ended yet. Now this amount, 24 ampules. So what was I saying? Okay, yes. So 24 ampules, right? So we are going to divide these ampules. And initially we are going to replace 1/3 of this, and then later we are going to replace 2/3 of this. But the main thing that we're concerned in the ER is the initial 1/3, because it goes in almost 5 to 6 hours, and this is the amount of time the patient is retained in ER usually, until stabilization. So 1/3 of this 24 ampules will go initially, right? Okay, so 1/3 of 24 would be 8. So initially, in initial 6 hours, we are going to replace 8 ampules, right? This is the value, right? Now, the thing is that in what solution are we supposed to be replacing the ampules? So the thing is that we are supposed to replace ampules ideally, and usually we are supposed to replace it, according to theory, in hypertonic saline. This is what the books say, okay? This is according to the books. But practically we do not have hypertonic saline, so we go for 5% dextrose always, you know. If 5% dextrose is not available in the hospital, ask the patient to bring it from the pharmacy, because you have to replace it in 5% dextrose. Now this is the problem, especially if the patient is a patient of CKD or AKI. If the patient has renal issues, okay, well, the thing is that, you know, 5% dextrose is what you're going to go for. But let's say that, you know, it's very it's a severe, it's like a massive emergency, and you do not have, and the patient does not have any cash on him, and you know there's issues, and you have normal saline available, so you can go for normal saline if it is not. But this is the ideal thing, right? If it is not available, you can go for normal saline unless the patient has renal issues. If the patient has renal issues, never go for normal saline. Okay, this is extremely dangerous. Never ever go for normal saline if the patient has renal issues. If CKD or AK, always ask them to bring them 5% dextrose. Okay, and then you're going to replace it at a very, like at a mediocre rate, in 6 to 7 hours over. You can replace it 5 to 6 hours. Usually we replace the initial 1/3 in 5 hours. Okay, so that's how we're going to replace the initial portion of bicarb in the emergency.